Here is the full substitution matrix. The diagonal is the own price elasticities of demand. The off-diagonal elements are the cross-price elasticities. In econometrics terms, those are the spillovers. The spillovers are irrelevant for connecting the treatment effect to preferences. The treatment effect is just sigma, regardless how much spillover there is. The treated also experience spillovers. So when we have a larger treatment share, that means a greater spillover for everybody. It gets differenced out in the treatment effect. Our metric of spillovers is the sum of the off-diagonal, which works out to scale minus treatment effect. Most of this can be done without demand theory or without maximization. That is, the outcomes do not have to be prices or quantities. The treatments do not have to be prices or quantities. We could be talking about mortality or test scores or any number of other things. The proof is in our paper, but the only assumption needed is that the T and K are comparable in that treating them both equally will not affect the gap between their outcomes. We looked at quantity outcomes from price treatments. To have price outcomes from quantity treatments, which is more like our figure 1, invert the treatment effects matrix. The algebra of this inversion is clean due to the Hicks-Marshall structure. The weights stay the same, and we just replace epsilon with its reciprocal and sigma with its reciprocal. For figure 1, which assumed perfect substitutes, the sigma terms disappear because sigma is so large. That is, quantity treatments do not change the ratio of the two prices. Because it has price as the outcome, this expression helps in the study of wages, which are prices in the labor market. Let's look at a few wage determination examples. The first is the union wage effect. The union is going to restrict the supply of labor to its part of the economy in order to increase wages there. The workers unable to be in that sector go to the other sector. That means delta T is negative. Delta K is positive and proportional to delta T because the non-union sector is absorbing the reduced T sector labor. The proportion is the relative shares of the two sectors. Local to a zero non-union premium, there is no aggregate output effect. That is the second-order property we saw in the excess burden chapter. These are the two expressions for the log wage effects in the two sectors. They have only the substitution effect. Union wages go up and non-union wages go down. The union wage increase is the treatment effect on the treated or taught. Here is the did, which is the estimator commonly used in the literature on union wage effects. It exaggerates the taught due to the negative effect on non-union wages. This got a lot of attention in the early union wage literature, but not so much anymore.